So these are some great slides, and the most important thing is if you want to be playing with OpenTelemetry, you need a backend to talk to. I work at Lightstep, and we're providing free community accounts for life. We set this up specifically because we work on OpenTelemetry ourselves. We helped found the project, and we want to have an awesome place for people to be able to experiment with tracing and make it work for them. So we have a free community account. It's not a trial or anything. It's just a place you put your email in, so you're not a robot, and you'll get a free account. And that's an easy way to go through these walkthroughs and play with OpenTelemetry. I should warn you, I looked at the Go walkthrough that I have, and the Go API is actually in a bit of flux right now. So this is a little out of date. So it may not compile against the newest version of Go, but I will be updating this after the workshop. So I keep these workshop examples generally up to date. It's not up to date right now, but I will continue to keep these up to date. So you can always come back here and look at these basics examples, and they contain with them examples of how everything works. And I'm also going to be adding a lot of comments to this afterwards. So this will be a nice, clean, commented example code that you can copy paste from when you're doing OpenTelemetry and Go. So that's my initial spiel. How are people feeling? Great, awesome, nice to meet you. Okay, so we'll wait till about 9:10 here, and then we'll get kicked off with an overview. But really, I want to know why people are here. So if people, I know it's just it's easy to be shy on these things, especially with like the video camera off and everything. But it's really more valuable to understand what people are looking for. Nice to meet you, Dulio, as well. Excited to see what OpenTelemetry is. Great. We'll just wait 2 more minutes. And again, if you're just sitting here, like, this is a good chance to just sign up and make an account. You don't necessarily have to try to run the code while we're doing this workshop, but it's a good place to start. And thinking about starting, let's just get rolling here. So again, you need an account. If you don't use Lightstep, you can use something like Jaeger is another easy example. You can run Jaeger in a Docker container locally, and that's another way to have a look at OpenTelemetry. That's pretty straightforward. All right, I'm going to just slightly rearrange my panel here. You guys can't see it. Ooh, get back there. You guys can't see it, but Zoom puts a bunch of Chrome on my screen, and so I can't full screen these notes. So I'm just going to leave them kind of looking like this for the time being. Hope that's okay. But let's get started. Dulio, I hope I'm pronouncing that correctly, mentions that he's in college, wants to see what all these tools are. Great, yes. I think it's important to start your career learning about some of these tools like distributed tracing, because while they've been around for a while, they're only going mainstream these days. So there isn't as much public history around how to use this stuff, but it is great. And I think it's better than just using traditional tools, as I hope you'll see. But let's dive into it. So first and foremost, let's just start with the name OpenTelemetry, because we picked this name for a reason. The term telemetry describes the scope and boundary of the part of the observability problem that this project solves. So telemetry means collecting observations about a faraway remote object and then transmitting those observations to another tool that's remote for analysis. So the telemetry part is the generation of those signals and the transmission of the signals. And that's the boundary of OpenTelemetry. There's also analyzing those signals, which is what Jaeger and Lightstep and other tools do, but that's actually separate from the OpenTelemetry project. And as we dig into the architecture, we'll kind of explain why we have that separation. So when you hit OpenTelemetry for the first time, it is a large project. It has a lot of pieces. You don't actually have to touch that many of those pieces to get started though, but it's useful to have a sort of high level overview of what the architecture of OpenTelemetry is, because that will make the rest of it make a lot of sense. So the basic architecture, if you're looking at a service here, we install a client in every service that wants to be observed. And we refer to that client as the SDK, or software development kit. So the OpenTelemetry SDK is a framework. It has all of the kind of frameworky hooks that you would expect. So it has lifecycle hooks, so you can intercept any of the observations being made or any of the API calls being made. And then it also has high-level plugins for doing things like exporting your data off to a backend. So when you want to use OpenTelemetry, the first thing you have to do is install the SDK in every service that you're using and configure it to talk to the backend that you want to talk to. The other piece that you're going to interact with a lot as an application developer is the OpenTelemetry Instrumentation API. So the SDK is the implementation, and you set that up when you're starting your program, but you don't want to actually reference that implementation in your code. In your application code or in a library you're writing, anytime you're writing instrumentation, you just reference this API package. And the difference between these two packages is the API package only contains the interfaces. It doesn't contain the implementations, so that means when you import the API package into your package, you're not hauling in a huge dependency chain. So the SDK might be using gRPC. It has a lot of stuff because it's an actual implementation. The API packages have almost no dependencies because they're just the APIs, they're just the interfaces. So when you reference the API package from your application code, that's ensuring that you've got this neutrality, not just between different vendors, but also neutrality against our implementation. And this ensures that you're not dealing with like a bunch of version conflicts and things of that nature. So when you use OpenTelemetry, you install the SDK in your startup, and then when you go write instrumentation code, you do that against the API. So that's the basics when you're using OpenTelemetry as an application developer. So the way this works in general is you can write instrumentation in your application code, but actually when we start with OpenTelemetry, you want to start not with your application code, but with all of the usually open source libraries that you're using to manage your code execution at runtime and to manage your networking. So usually for web services, the code that manages your execution is a web framework of some kind. In Go, web frameworks aren't as popular as in other languages, but the standard lib does come with like essentially basic web frameworks in terms of its HTTP package. So instrumenting that framework is an important part of using OpenTelemetry. And so we provide instrumentation out of the box for all the major frameworks and standard library packages that you'd want to use. Besides the web framework that you're using, anytime you make a network request, OpenTelemetry needs to know about that. So your HTTP clients, your database clients, your message queues, anything like that needs to have instrumentation either baked into that library or added to that library as a plugin. So when you set up OpenTelemetry for the first time, you also need to set up the instrumentation for the open source libraries that you're using to manage your code. And in some languages, we can automatically install all this stuff for you. Golang is a very manually focused language. It's not a language community that wants a lot of magic or automation. So in Go, we tend to just write very boring basic code that you can copy paste to get this stuff setup. So when you set up OpenTelemetry, you're going to install the SDK, and then you're going to look for library instrumentation that's available from us in our contrib package, or sorry, our contrib repo, and you're going to install that. And so that's how you get started with OpenTelemetry, installing the SDK and installing the instrumentation. And then that instrumentation gets hooked into the API. None of that instrumentation depends on the SDK, and that allows that instrumentation potentially eventually to get baked in directly to these libraries. So we hope that one day libraries won't require some kind of plugin in order to work with OpenTelemetry. They'll just have this OpenTelemetry API baked into them, and then all you have to do is install something that observes your system, and that observer will automatically get hooked into all of the pre-existing instrumentation. So that's the long-term goal for OpenTelemetry, but we have to become much more stable before people will start baking it in. In the meantime, we use instrumentation plugins. In addition to what you run inside of your program, we have another tool called the collector. The collector here, the way this thing works is it can be run as a sidecar, or it can be run as another process in your local network. You can tier them, and what the collectors are for is therefore pipelining your data from your applications to wherever it is that is eventually going to observe that data. So the collectors can buffer the data so that you can get it out of your machine. You can move most of your configuration over to the collectors, just have your SDKs left in a kind of stock configuration talking to a local collector, and then you can do your configuration in the collector. You can also process and manipulate your data in the collector, so you can scrub data, you can remove sensitive data like passwords, you can use it to say update like old conventions you're using to new conventions if you're switching data sources. So just sort of managing your data pipeline is what you use the collector for. You don't have to run it. You can just run the SDKs with an exporter that talks directly to a backend that you're using. So the collectors aren't a requirement, but they are a useful thing to run, especially when you start doing observability at scale. And these collectors, as well as the SDK exporters, support a variety of formats. So OpenTelemetry has its own data protocol called OTLP. I think it's the only protocol out there that supports both tracing and metrics, and logging coming soon. So rather than having metrics getting emitted by a metrics program and having your traces or logs getting emitted by a tracing or log program, we just have one data format that's describing everything going on in your application. So that's OTLP. And in addition to that, we support a number of pre-existing data formats. So Zipkin, Prometheus, Jaeger are the common examples. Of course, there are plugins to work with X-Ray and Datadog and Stackdriver and things of that nature. So you're not stuck with OTLP, though we do recommend people switch to OTLP, and we're hoping that to see more and more vendors and backends use OTLP native. But in the meantime, you can use your collectors to kind of manage how you're sending this data. And you can even tee data off, so you can be sending, say, your tracing data to Zipkin, and then your metrics data over to Prometheus. So there's a lot of flexibility in your setup that you can do with the collector. What we don't include is analysis. So the collector sends data to some backend, but we don't provide a backend ourselves. And the reason for that is this is a standardization project. We want OpenTelemetry to be a standard language for describing what systems are doing. So that's really the focus, is standardizing how systems describe themselves. And you need the standardization because we're talking about distributed systems now. So it's lots of services talking to each other. And there are new languages and new frameworks and new everything that are getting developed every day. And those new things need to be able from day one to start describing what they're doing. So OpenTelemetry provides a language, which is represented in our API and in our data format, OTLP, that can describe everything that a service is doing and describe it from the perspective of these distributed transactions that we're trying to observe. So for that reason, we don't provide any analysis, because analysis is not really where you standardize. Analysis is what you're doing with the data, and we expect OpenTelemetry, by providing such good data out of the box, to actually, we're hoping to see some kind of golden era where more and more observability tools get written against the OpenTelemetry data. Since in the past, you would have to build this whole telemetry system if you wanted to build an analysis system, you don't have to do that anymore. You can just leverage all of the instrumentation and data OpenTelemetry provides, and then build your own analysis tool. Or of course, use one of the many tools that are already available, and then switch from one tool to another very easily, because they're now all supporting the same data format. Obviously, what you set up within these tools might be different and might not be portable, but at least your data is now portable. For some reason, this thing keeps moving around on me. Okay, so that's the scope of the project. How we manage all of this code is through something called the specification. So OpenTelemetry is implemented in a bunch of different languages, and we want to ensure that the implementation is consistent across those languages. So what we do is we write that all down in a spec that's a language neutral document. We work on that together, and then we release a version of the spec, and then that version gets implemented in all the different languages. And so the structure of OpenTelemetry as a project is we have a technical committee that's in charge of the spec, and then maintainers for each language. And those groups work together to create this feedback loop where we learn things, add more to the spec, and then implement it once it's in the spec. And that's the basics of the project. Any questions at this point? We're going to move on to how you use OpenTelemetry and like what the mental model is. But if you have questions about like the overview of the project or the project structure, feel free to toss them into Q&A or toss them into the chat. I'm not going to stop because we don't have a lot of time, but just go ahead and throw your question in there and I'll get to it. As I mentioned, we don't have a lot of time, so I'm going to move on to the next step here, which is transactions. And this thing keeps moving on me. But just to be clear, we're going to spend the next, say, 10, maybe 15 minutes just doing more of this overview, and then we're going to get to a code walkthrough at that point. But let's go over the basics of what you're trying to do with OpenTelemetry, because this mental model, I think, is really important. And once you grasp this mental model, the rest of OpenTelemetry is going to make sense. So the core thing that you're trying to solve with OpenTelemetry is distributed transactions. You want to monitor a distributed transaction. And so just to explain what that is, even if you don't know what that term means, you're definitely already doing it. Let's imagine you have an application that is super basic. It's just a mobile client that lets you upload a picture and a caption, and then you can look at those on the web. So what does the transaction look like for uploading a photo and a caption? Well, you'd have your mobile client. That would be the first piece. And then that mobile client talks to a server of some kind. Now, of course, in the real world, it's not that simple. The most basic version of this that's realistic that I can think of is that client would actually talk to a proxy of some kind. That proxy would then talk to an authentication service to verify that you're allowed to perform this action. If you authenticate, then that proxy uploads the photo for you to some local scratch disk. And once that's done, calls a local application server with the location of that photo and the caption. The application server then can upload, process and upload that photo to cloud storage, like let's say S3, and then stores the location of that, that photo URL along with the caption and some data service. And that data service is, let's say, sitting in front of a mix of MySQL and Redis. So the data is stored in MySQL and then cached in Redis. And the data service sits in front of those two things and manages pulling from the cache and whatnot. So, I mean, I've been doing web development for like, 15 or 20 years, and I see this setup all the time. So this is nothing new. This is like an old LAMP stack would look similar to this. But you can see even in like this most basic of transactions, there's like what, 1, 2, 3, 4, 5, 6, 7, 8 different services involved. So even the most basic kind of monolithic application where you only have one app server that does all of your appy stuff, even in that world, you're still doing this kind of distributed transactional approach. And when you want to monitor what's going on in this world, you want to understand the flow of execution that occurred in one of these distributed transactions. And you want to understand where the time and resources were spent in that transaction. So we might look at this transaction from a sort of service map like this, and this will tell us some good data about which services are involved, but it doesn't tell us the sort of order of operations, like what actually happened within each service. You can guess, but you can't tell whether the proxy called the app server first and then the auth server or what. So to get a more concrete view of what these transactions look like, we tend to draw them like this. So this is what's called a trace diagram. And so this is the exact same, the colors match the colors of the different services here. The length of the line represents the amount of time that particular operation took. So we have a client operation here. And since it's a synchronous transaction, that took the most amount of time because it's waiting for everything to get done. And then these arrows represent network calls. So this client calls the reverse proxy. The reverse proxy then calls this application server, this auth server, then it uploads the photo, then it talks to your application server. The application server spends some time talking to S3, and then it talks to this data service. And then it all eventually goes back to the client and says 200 success, photo uploaded. So this is a very useful diagram because this can tell you a lot of stuff right out of the box. First of all, you can tell where the time went. It's not necessarily the longest span, and we call these things spans because they measure a span of time. So even though this client span is the longest, it was spending most of its time waiting. So primary thing you do with tracing is identify where the time actually went. So we want to know if we're going to optimize this transaction and make it shorter, where should we focus our efforts? And so identifying where the time actually went and identifying where systems were just hanging around waiting, that's one of the things you do with distributed tracing. So for example, if I was thinking about optimizing this data service, if I looked at this trace, I would realize that's not actually worth my time to optimize this data service because it's only contributing a tiny amount of the overall latency. And really, if I want to optimize this request, I have to find a faster way to upload the photos to my scratch disk and then upload the photos to S3. And if I optimize anything else, it's not really going to make too much of a difference. So figuring out that kind of information is, of course, something you do with tracing. You also want to find errors, right? So you want to know if there is an error, if a certain request is erroring out. You want to get alerts for that. And then you want to be able to root cause where the error happened. So maybe this is all coming back to like a 500 error on the client and you're reading that, but you want to know, was that error coming from the auth server? Was it coming from S3? Was it coming from this data service over here? You know, quickly identifying where the error came from. And once you find that error, being able to quickly and automatically see the rest of the transaction is a core thing that you do with with tracing systems. You do this with logging systems too, but with a tracing system, being able to find all this information is automated. Whereas with a logging system, you kind of have to do a bunch of search and filtering to even collect the data that would represent this transaction. And like logging systems, you don't just have these high-level spans representing these large operations. You also have events. So we don't call these logs, we call them events, but trace events are effectively logs. So this is kind of like structured logging. So the way you use OpenTelemetry is you set up these spans, usually in like your framework or in an instrumentation plugin so that you're not managing them in your application. And then from your application code, you're just accessing these spans. You're adding event data to them as logs. And then you're also adding what we call attributes, which are correlations. So you want to be able to understand if there's an error that's occurring, what correlates with that error? Is this error being emanating out of like a particular region? Is there one host that's erroring on everything? Is it a particular URL that's erroring everywhere? Is there a project ID associated? So maybe this is an update account endpoint and there are errors coming from update account, but you realize that this is actually correlated with only a handful of accounts. Most accounts don't have this problem, but some accounts are consistently erroring when you try to update them. Those kinds of correlations help you get to the bottom of what's actually wrong. You have to eventually root cause the system by kind of looking at an execution trace and understanding, okay, these things happened and this particular thing that was wrong or weird. I know how to go fix this in my code now. But to get to that point, you have to figure out what is that execution trace that I want to look at. And so to do that, you need these correlations so that you can quickly move around and identify what's related to what. So all of this stuff is what you get out of OpenTelemetry out of the box. And you can do all this stuff with traditional tools. You can do this with logs and metrics, right? And the way you do that is you get a metrics alert, you go to your metrics dashboard, you take a ruler or a piece of paper, if you're me, you line that up on your screen where one metric went squiggly, and then you scroll down through your dashboard and look for all the other metrics that maybe went squiggly at the same time that other metric went squiggly. And then try to figure out what that might mean. Then go over to your logging system and try to dig up some logs that you think are relevant to those metrics and those alerts. You're doing the same thing with tracing, but all of that's automated. If you are seeing alerts coming in from some aggregates that you've made out of these traces, aka metrics, so you're seeing an error rate has gone up or latency has spiked on a certain thing you're monitoring, from there you can just look at example traces because all of this data is connected to each other. So you don't have to then go find and guess at what transactions were responsible for that latency. You can go straight from looking at a metric telling you that you've got a certain percentage of slow requests, and from there look at examples of those slow requests. So you can do that with traditional tools, but I think you'll find once you get used to tracing, you'll go back to your logging tool and you'll be like, wow, I really waste a lot of time collecting all of this data before I can analyze it. Sort of like when switching to Go from other languages that didn't have automatic text formatting. That was not a thing I realized was a huge waste of my time until I switched to Go and just had all the text formatting happen automatically for me. I got used to that. And then when I switched back to other programming languages, suddenly I was like, oh my God, I cannot waste this much time pressing tab over and over again. And I went out and tried to find language formatters for those languages. They had existed prior to Go, but I didn't really realize how much time I was wasting dealing with formatting. And that was just not something I had to do. I could just automate that away and then focus my efforts on the important part, which is solving my problems. And so what Go did for code formatting, something like OpenTelemetry does for observability. It just makes all of this data connected out of the box, and it makes the act of observing this stuff a lot more straightforward. Okay, So digging in a little more than I usually do. Let me know if you have any questions on this stuff. There is one big concept, though, that ties this all together, which is context propagation. This is the one thing that's really different from traditional observability tools, is you have to do this context propagation in order for any of this to work. And understanding context propagation is sort of the core architectural piece that you have to understand about OpenTelemetry. You don't have to interact with this system very much, but you do need to know that it's there because it helps your mental model. So if you can get your head wrapped around context propagation, then the rest of OpenTelemetry is going to make plenty of sense. So let's go over that. So context propagation means I want all of these logs to have the same transaction ID. That's, at the end of the day, how we look all this stuff up. If you find a log and you want to know all the other logs that were in that transaction, you need a transaction ID. Otherwise, you can't do it. You might have a request ID available on some log, and then you'll find one hop, the things that were on either side of that request. But then if they're like we were looking at, here in this system, there's more than one hop. So you can't, if you only have request IDs that tell you about an individual hop, you have to glue a whole bunch of stuff together to see the logs that are in this entire trace. So rather than do that, what you want to do is propagate a transaction ID. So you want to have your service, let's say this are two services talking to each other. The first one kicks off an operation, does a couple more operations, then it makes a network call to service B and continues onwards. To glue all this together, you need to have some kind of context that flows through this whole system. So that at the beginning of this operation, we can create a transaction ID, put it in this context object, and have that context object follow the flow of our execution. So the part that's following the flow of execution within a program is called a context object. And in Go, we totally know what this thing is because Go has context as like a first-class citizen. We literally have an object called the context object. We have to pass it around by hand, which is kind of annoying. That's Go, sticking to manual and obvious is better than automatic and mysterious. But nevertheless, this is a first-class concept in Go. So I think Go programmers get this better than people in other languages where they're not interacting with a context object all the time. So you're taking your important IDs, you're sticking them in context, and then that's going along. What's different, though, is when you hit this network request, you now have to send this context and continue it on in the next program. And Go doesn't do this out of the box. And we call that process of taking the context and serializing it onto a network request propagation. So what you do is when you make the network request on the client, we say you inject that context into that request. So in HTTP, that means adding extra headers that contain this context information. Then you propagate it, and on the server side, you extract that context, deserialize it into a actual context object, and then that context object continues to follow the flow of execution. So this is the basic architectural model of OpenTelemetry. There's this context going on in the background. It's getting propagated through the plugins you installed on your networking clients and your servers. And once that is all set up, then everything you do with the API happens on top of this. So you set this stuff up by installing OpenTelemetry and installing plugins generally, perhaps writing some instrumentation plugins if you're using, say, a homegrown framework that doesn't have instrumentation available for it. But usually this should get set up and managed by all that framework code. And then within your application, you're just doing things that look a little more like what you're normally doing, setting attributes, logging, stuff like that. But when this breaks, you have to understand that this exists so you can go fix it. And one thing you have to pick is what kind of propagation headers you're going to use. Obviously, these systems have to agree. If I'm going to inject a context into some headers, this other system has to know what headers to look for in order to extract that context. And there are some like de facto standards here. B3 from Zipkin is a set of tracing headers that have been around for a while, but we wanted to do something better than that. So we are actually working with the W3C to add official tracing headers to the HTTP specification. So these are kind of worth looking at. Trace context is available today. This will be added to maybe the next version of the HTTP spec. It'll be coming out soon. But it's very simple. You have one header called trace parent that contains the trace ID. That's this transaction ID that has to get glued to every event. It includes the parent span ID. So that's the ID of the parent operation. So in OpenTelemetry, we have these two ID spaces. There's the space for all the events in the actual transaction, and then there's the ID for all the events that are just in one span or one operation within that transaction. And that gives you a graph of how your code is executing just by having your events be associated with these two IDs. There's also some additional information like sampling. Are we only sampling a portion of the events that are happening, to deal with scaling issues? There's something called trace state, which is some internal stuff that you don't have to worry about. That's just for tracing systems to talk to each other. And then there's another set of headers we're adding called baggage. And baggage is just literally arbitrary key value pairs. So it's not trace specific. It's just anything as an end user you would like to add and propagate. For example, you might have a project ID that's available upstream, but would be expensive to grab downstream. And you want to use that project ID as an index. So you can add that project ID to baggage, and then it will get propagated downstream, and then you can pull it off of baggage. So you can think of baggage as just the Go context object, only now it's a distributed context. So that context object, things you pull in and put in and pull out of its bag, will actually get propagated and be available downstream. And so this basic concept, everything in OpenTelemetry is built on top of this ability to propagate this information downstream and have it accessible to later services. Okay, that's really everything for the overview. We're going to do a quick code walkthrough next in order to dig into these API calls. But oh good, we've got a question coming in. And please write, this is a good time to write questions if you got them. So how is context key uniqueness maintained when propagating to a service? Is this not an issue? So yes, that's important. Keys need to be unique. And the way we do that is just by having enough randomness. So tracing keys are 128-bit these days, and span keys are 64-bit. And so that combination, assuming your random number generator is working correctly, that is enough randomness that you don't get collisions, because the span keys are contextualized within the trace keys, and the trace keys have 128-bit of randomness. So that's how it's dealt with. If you don't have that randomness, then yeah, it'd be very hard to do. Cool. That's a good question. All right. Well, I'm going to keep rolling on. We're going to head over to our code walkthrough here. So this is going to be a walkthrough of this OTel basics. Again, this is super duper basic. And I do have to stress the Go API did change very recently. So I'm going to update this to the latest API, but it's the same concepts. The concepts haven't really changed. We've just reorganized them a bit. So when you set stuff up, here we are in my code editor. If we have a look, we've just got two files, the client and the server. This server, if you look at it, it's very basic. It's just a hello world server. So we have a handler that we're going to set up and just wrap in the core HTTP libraries that Go provides. And we're just going to listen at /hello on port 9000 and write back hello world. So that's all we're doing in this server. So how do we add OpenTelemetry to this? Oh, and I should mention the client. All the client does is it just spins up and just makes 5 requests in a loop and then shuts back down. So how would we trace this very basic system? The first thing you have to do is you have to install OpenTelemetry. You have to install that OpenTelemetry SDK. The way you do that is in your main function. You configure OpenTelemetry. Most of the configuration you're doing is about talking to a specific backend. So in OpenTelemetry, we're adding this concept called OpenTelemetry Distros, which are just prepackaged versions of OpenTelemetry that do that configuration for you. Lightstep comes with a distro called the OpenTelemetry launchers. And all this does is it gives you, it hauls in all of the correct dependencies when you install it. And when you call configure OpenTelemetry, it produces back the OpenTelemetry SDK object. And it just pre-configures it for you with a bit simpler configuration. If you look at how you do this out of the box with OpenTelemetry, you have to create several different pieces and then kind of wire them together. And this just makes it a little bit easier. But it's still just OpenTelemetry. All this is doing is just like an easy configuration layer for you. The stuff you need to configure is the service name. You need to name every service in OpenTelemetry or you can't find them. If you're talking to Lightstep, you need an access token. So the way you do that is if you go into Lightstep and you go to this settings page, you'll see this access token here. So you just copy that and paste that into here. You need to decide which propagators you're using. This was getting back to that context propagation issue. Every system has to be configured to use the same propagators. The main options are trace context and B3. And then if you're going to use baggage, then you want to add the baggage headers as well. And if you add all 3, what this does is it creates a compound propagator, which means that it'll actually propagate all 3 types of propagation. So even though B3 and trace context overlap, it can be useful to propagate both if you're trying to transition from, say, B3 to trace context. So I think with the launchers, this is B3 by default, but it's going to be switching to trace context as that becomes the standard. So that's just some deets. You do want to pay attention to this setting when you're rolling out OpenTelemetry. And then you can also add resource attributes. So resource attributes are just how you describe your service. So you have your service name, but you might have other things like container ID, host name, stuff of that nature. And so you can add all of those as resource attributes. And then all data that gets emitted from this service can be findable with those resource attributes. So those are important things to add as well. And all of these official attributes, they're all defined in OpenTelemetry. We call them semantic conventions. So what this means is, like, rather than going in here and being like, you know, having something called host name, or maybe someone else calls it host dash name, or someone else calls it host, we just want to have one, you know, one convention that's just, you know, let me see if autocomplete will find it. We just want to have host name, right? And have host name be the same everywhere. Everywhere people write down host name is written down in the same format. And so all common attributes in OpenTelemetry follow one of these semantic conventions. And you can look those conventions up in the spec. So you set OpenTelemetry up, the launcher, and then you shut it down when your program exits. And the shutdown allows you to flush any remaining data before the system shuts down. So that's important to run as well. So that'll get the SDK set up. the next thing you have to do is you have to add instrumentation to anything that you're using. As I mentioned, in other languages, we can add this automatically, but in Go, you have to add it yourself. So these packages, you can find them in OpenTelemetry.io contrib. Instrumentation contains all the instrumentation packages that we currently have. So you can go look there. If you see something missing that you want, you could try writing that instrumentation and submitting it to OpenTelemetry. That's a good way to learn how OpenTelemetry works. Look at some existing instrumentation and try to make your own plugin. So in this case, we have an HTTP server. And so the way we add instrumentation to this is we take our handler, this hello handler up here, this guy, and then we wrap it up in an OpenTelemetry instrumented handler. So pretty basic, right? We're just making a new handler that wraps the old handler, and then we're adding that wrapped handler to HTTP. Likewise, on the client side, the way you do this is when you make a new client, you wrap the transport. So there's an instrumented transport that you can use to wrap whatever transport you're currently using. So this is just a bit, when you get started with OpenTelemetry, you do have to find these packages and install them. So that is one bit of work you have to do. But it's usually some pretty straightforward copy-paste effort to get these in. So installing the wrapper for the client transport and the wrapper for the server handler, that gives us automatic instrumentation for the handler and the client. So that's how you'll end up. I don't have it connected to Lightstep right now, but that will give you one of these graphs that we were looking at earlier. So you'll be able to get traces that look like this right out of the box just by installing the launcher and installing the handlers. So I want to emphasize, you don't actually have to write any instrumentation code to start getting data out of your system. So step one when setting up OpenTelemetry is just to get this set up. Get the launchers installed, get the instrumentation installed, and then you'll start seeing your traces propagate, and you'll see high-level tracing information for your service. And that information is usually granular enough that you can start alerting and monitoring off of that. And then later you can dig back in and start adding more data into your application code. But when rolling out OpenTelemetry, because we're trying to monitor these distributed systems, it's better to go broad than to go deep. So step one is just, without writing any instrumentation by hand, try to get OpenTelemetry set up and propagating your context just with plugins. So that's my strong recommendation for getting started with OpenTelemetry. Just get it working with instrumentation plugins before you start looking at adding additional data in your application itself, and get it working across all of your services before adding detail to any one service. If it's too hard to add OpenTelemetry to all of your services because it's a manual process of adding it, you have to go to lots of teams to get this done, then just pick a high-profile target. So an important transaction that you want to monitor, either because you know it's having trouble or because it's just important, like, checkout is maybe a really important transaction that you just want to monitor. And so if you pick a goal, like we want to monitor checkout, and then add OpenTelemetry to all of the services that interact with that transaction, that might be less than adding OpenTelemetry everywhere to everything. So that's a good way to start. So I strongly recommend getting these complete traces going before you add data, before you add any detail. Now, that said, let's look at adding some detail. So how does that actually work? So if you've set all of this stuff up, you'll automatically be getting a span that measures everything about your HTTP handler. It'll add all of the semantic conventions for HTTP and networking onto this. So you don't have to do any of that in your code. You don't have to to log that it was a 500 or 200 or anything like that. That all happens automatically. But you may want to add application level information. And so the way you do that, you haul in the trace package, and for anything that has been instrumented, you grab the context object. So from this case, we're getting the context object from our request, and then you can pull the span out of the context. This is the current span that was set up by the HTTP server instrumentation. Once you have that span, you can add attributes to it. So for example, if I want to set a route key, this is like my hello route. So maybe it's like hello person is like the actual route pattern that you are using here. So we have a convention called HTTP routing. So you could add this as an attribute, for example, if you want to be able to find your endpoints by route. And if you want to create your own child spans, the way you do that is by grabbing a tracer, calling start on the current context, and that will make a child span in a new context. And then you always need to end that child span in order to measure the time from when the span started and when the span ended. If you do this, then this new context has this new span in it. And so anything downstream that grabs this context, when they call span from context, they'll be getting your new child context. And so that's how we manage which span is current. So we call the span that's in the context available to you right now the current context. So the general pattern is when you're in your application code, you don't really want to make a lot of child spans. You certainly don't need to make one per function. Mostly what you want to do is have all of this managed, outside in some kind of wrapper. And then in your application code, all you're doing is, just not even necessarily holding on to these things, right? You can just chain it and say, grab the span and add an attribute to it. You can see it's like pretty easy to even take something like this and wrap it up in a like little helper function, right? Like something like this. So I recommend people create little helper functions like this if this is a little annoying to write. You'll find some patterns that you're doing all over your code base, and you can just simplify them. Besides setting attributes, there's a couple other things we can set on our traces. So attributes are the indexes that you're going to use to find these different operations. But besides these span level attributes, we also have individual events that you can add. So this is going to replace the way you normally log. And you can even take your existing logs potentially and pump them into your spans as events. That's a useful thing to do to start getting a lot of extra data into your tracing system. But the way you add an event to a span is pretty straightforward. You say add event, you pass in the context. You'll notice that all of these tracing methods take a context as their first argument. But you just add an event, you have the event message, and then you can attach structured data to that event. So the same way you can attach attributes to a span, you can also attach attributes to an event. You can attach attributes to a resource. You will be able to attach attributes to metrics. So attributes are just this generic concept of key values for being able to index these different kinds of things. There's a special kind of event called an error. Errors are super important. They're just recorded as events, but we have a helper function to ensure they're always formatted correctly. So when you want to record an error, you just call record error. And then if this error changes the status of the operation, then you want to set the operation to error. So what this means is just when not every error means the operation has failed, right? Like you may get an error back that a file wasn't found, but maybe it's normal for a file not to be found. And if a file's not found, you then create the file. So file not found in that case wouldn't be an error that causes the whole operation to fail. It might just mean the operation did something different. So you can still just record errors and not have them fail the operation. If you want an error to fail the operation and you want that operation to register itself as an error and create alerts and let you count those errors and do all of that, then the way you do that is by setting the status on the trace, the status on the span to the error status. So it's really simple. We only have 3 statuses: unset, error, and okay. Unset is the default. Error is what you set it to when it's an error, and okay is optional. That's used to suppress automatic errors that might have been generated. So you don't really have to worry about that one. Mainly, you just need to know that if you want a span to count as an error, you have to change that span status code to error. And let's see if we have any other good examples in the client. And we don't. And that's it. That's literally all you need to do. So if you learn these basic commands, how to set up OpenTelemetry with the launcher, wrap your instrumentation with our instrument, wrap your clients and services with our instrumentation. And then in your application code, all you're doing is grabbing the span out of the context and then setting attributes, errors, and events on that span. And that's it. That's all you have to do with OpenTelemetry. And if you get all that set up, then you will have switched from logging to tracing. And if you start using these tracing systems in addition to your logging systems, you're going to discover that they provide a lot of features out of the box that were things you were already doing with logging, but were just spending a lot of time and effort to do that are happening automatically in a tracing system. And that's all I've got. This is a short workshop today. Again, I'm going to just repost these links so that you have them later. So you can walk away with the slides here. And then also look at these handy links. So just in case people miss them. And go. This quick start guide, this is a quick start guide I've written. This gets into everything in more detail. So here you can read just a lot more detail about how to access these different methods and what they do. So this is also a good guide. This repository will get updated to the latest version of Go. So you can always check back in with this. And it'll just keep getting more comments added and become a better resource to copy paste from. And that's all I've got. We're a little over time, but if people do have questions, I'm happy to hang out at this point and answer them. You're welcome. Thank you. And then, so Dan asks, is the idea to completely replace logging with tracing? Is there ever a need for a logger if you're using open tracing? So I would say this is a good question, Dan. The answer is probably it depends. I personally believe you don't, once you've switched over to tracing, you no longer need a logger. And what you can instead do is take that tracing data and output it in a logging format. If you still want to be sending that data to the existing logging system you're already using. All that means is the data that goes into that logging system will now be more structured and will have these span IDs and trace IDs on them. So you can use those in your existing logging tool and just make it better. So I personally don't think there's a great reason to continue to use logging once you've switched over to tracing. The only thing I might say there is sometimes people add sampling to their tracing, and sampling your logs isn't like a concept people are familiar with, because without that transaction ID, you can't sample them like very coherently. So that's, I would say, maybe the one gotcha is that if you turn sampling on for tracing and you're using that for logging, then your logging is going to be sampled. So that's maybe a little gotcha there. But more and more systems don't require upfront sampling in order to work. Cool. Any other questions? Sorry for going a little long. Says, I think it was a little advanced for me, but it's interesting to see all this works. Yeah, it definitely, if you're new to this stuff, I think once you've, you mentioned you were in college, and once you're trying to monitor these systems and operate them, then the need for this stuff starts to make a lot more sense. But if you're in college, I would say the thing to maybe focus on is optimizing code. If you want to optimize your system, think about how you would track down those latency issues. Figure out how do I find where in this program things are slow, and then go try to make them fast. That's like a good academic exercise, I think, to practice. I don't know that, personally, I don't think they teach as much of that stuff in college as they should. So that's what I'd recommend. Dan asks, is an OpenTelemetry service generally configured per route or just one per app? Like if serving 10 different routes, do you need configured 10 different OT services or just one? Yeah, so OpenTelemetry, you just set it up. Here, let me look at the code. You're just configuring OpenTelemetry once for your whole system, but you will have to make sure every handler is wrapped. So this is the part where in Go, I think it's a little annoying. Like depending on how your system is set up, you have to get things wrapped properly. So this bit, I think, may be a little tedious depending on how you set your system up. If you're using a framework like Gin, for example, then those things usually have hooks where all this stuff can go into. But if you're using the straight standard lib stuff, like this is the part you're going to have to do over and over again. So hopefully that makes sense. So, but you only need to do this part once per app, just to be clear. Yep, you got it, Dan. That's that. Cool. Okay, well, if there's no more questions, we're over time, so I'm gonna sign out. But I do want to just have some last minute things just to let you guys know. At the bottom here, we do have some best practices that I didn't get into. You can read about those. You can get help here. Here, let me paste this in. We do have Discord server where we hang out. So you can come there if you want to chat. You can also find me on Twitter. So like I'm at Twitter, I'm at Tetsuo. And I respond to DMs there. So that's another way to get a hold of me. And they did ask me to make this pitch here at the end, which is we're trying out a consulting service at Lightstep. So this is not for buying Lightstep the product, but this is just people who want to get their organization set up with OpenTelemetry. And it seems like it's wrangling a lot of teams, or it's like more of a project than you just want to do as an engineer. We are offering like a quick start consultation where some of us will come in, hands-on code, and help you instrument your system with OpenTelemetry. So that's not like a pitch for buying Lightstep. That's just if you want help getting OpenTelemetry set up for your system and would like to pay for that help, we're checking out offering that service. So you can just grab these slides, contact me or contact support at Lightstep if that's something you're interested in. So that's my pitch. Hope you all liked it. Definitely reach out on the internet and give me feedback. Always looking to improve these things. And I hope you have a nice day. Thank you very much.